In today's lesson, you will learn parabola terminology such as vertex, zeros, axis of symmetry, and optimum value. You will also learn how to identify the vertex, zeros, axis of symmetry, and optimum value of a parabola given its table of values or graph. Let's look at the simplest quadratic function, which is y is equal to x squared. You've already learned how to produce a graph of this function, and it looks like this. The key points of this parabola are 0, 0, 1, 1, 2, 4, and 3, 9. And the same thing will be on the other side. So as you can see, it's very symmetrical. And that could be obtained using table values. Another way of obtaining these points is starting with a vertex and using something called a step pattern, which is a key feature of this type of parabola. So 0, so we're going to go 1 along x-axis and 1 along y-axis, and then 1 along x-axis and 3 units along y-axis, 1 along x-axis and 5 along y-axis. And we'll do the same thing on the other side. 1, 1, 1, 3, 1, 5. And that would be a quick way to produce a graph of a parabola. Now, hopefully you can notice that these numbers are the first differences from a table of values. And this is how we use the step pattern. All right, and it will also correspond over here as well. If you see 1, 1, 1, 3, 1, 5, and the same thing on the other side. So the vertex could be anywhere. But what is vertex? Vertex is a turning point of the parabola, the bottom point on a parabola that opens up, or the top point on the parabola that opens down. So some parabolas will open down this way, and this will be the top point, top of the hill, and the bottom point of a valley. All right, so this parabola has a vertex at the origin, and the coordinates of this vertex will be 0, 0. If you look at over here, this parabola has a vertex at a point -1, -8. So we can just say that the vertex is -1, -8. And this parabola also opens up. It means that it does not have a maximum value. It will continue this way, but it has a minimum value at the bottom point. The lowest point of the parabola is the vertex over here, and it's -1, -8. Now, the other key feature are the zeros. What are zeros? The zeros are actually just the x-intercepts, which is x values for which y is equal to 0. So over here, if we look over here, there's only one x-intercept, and that x-intercept is 0 when y is equal to 0. In this parabola, parabola crosses x-axis in two spots, at this point and at this point. So it has two x-intercepts, two zeros, and those zeros are -3 and 1. All right, so another key feature of a parabola is something called axis of symmetry. Axis of symmetry is the vertical line that divides the parabola into two congruent halves, two symmetrical halves. And we usually sketch that line with a broken line, dashed line, and it goes right in the middle and always goes through the vertex. So for this parabola, axis of symmetry will be right here. And it actually goes along the y-axis. And we usually write the equation for this axis of symmetry, and in grade 9, you'll learn that the equation of a vertical line will be written in a special way, and that equation is x is equal to 0 for this one. So over here, the axis of symmetry goes along x equal to -1. It will divide this parabola into two equal symmetrical halves. It goes through the vertex, And the axis of symmetry, the equation for axis of symmetry will be x is equal to -1. And what you can notice is that the x-coordinate of the vertex matches where the axis of symmetry falls. Okay, so another thing to discuss is something called optimum value. That could be maximum or could be minimum. So the maximum y value of a parabola that opens down, or a minimum y value of a parabola that opens up. This parabola opens up, therefore it will have a minimum value, the lowest y value, and over here the lowest y value is 0. So we will say minimum value of 0, or y is equal to 0. In this parabola also opens up. It also has a minimum value, but this minimum value will be now -8. So we'll say that the minimum value for this parabola is -8, and it also opens up. Now, I would like you to notice that the minimum value of any parabola matches the y-coordinate of the vertex. So it will be very easy to know what the maximum or minimum value is if you know the coordinates of the vertex. So -1 is where the axis of symmetry falls, -8 is the minimum or maximum value. So minimum value of a parabola for this type of parabola, and in general, y-coordinate of a vertex will correspond to a maximum or minimum value of a parabola. Now let's learn how to read those key features of a parabola from a table of values. So, given a table of values for a quadratic function, determine the zeros, the equation of the axis of symmetry, the vertex, and the optimum value. All right, so this is my table of values, and first I will find the zeros. The zeros are the x-intercepts, right? X-intercepts occur when y is equal to 0. So then I will go to a y column, find where the y is equal to 0, and this will happen to be one of the x-intercepts, and this will be the other x-intercept. So therefore, the zeros are -3 and 1. All right, now I have to find the axis of symmetry. I do know that this axis of symmetry divides the parabola into 2 equal halves and will be, in this case, equal distance from the 2 x-intercepts. So I know this is my one of my x-intercepts. I know this is the other one. So then I will find how many units separate them. So it's going to be 1, 2, 3, 4, because I see that the x values go by 1. Therefore, halfway will be just 2 units away from each of those x-intercepts. It's going to be 1, 2, and this will be my x-coordinate, x value where the axis of symmetry falls. So therefore, equation for it will be x is equal to -1. All right, now let's find vertex from a table of value. Well, I do know that axis of symmetry always goes through the vertex. So therefore, this must be the x-coordinate of the vertex. So if this is the x-coordinate, this will be the y-coordinate of the vertex. The vertex is a point at which the graph intersects the x-axis. So therefore, the vertex is -1, -4. And the last thing to establish is the optimum value. Well, optimum value is always the y-coordinate of the vertex. So I see the y-coordinate of the vertex is -4. So this is going to be the optimum value. Optimum value will be y is equal to -4. But at this point, I still have to establish whether it's a minimum or a maximum. So how do we do this from a table of values? Well, in the previous lesson, you learned that if the parabola opens up, then it's a minimum value, and if it opens down, it's a maximum value. You also learned that if the second differences are positive, therefore the parabola opens up. and that will give me the minimum value. And if the second differences are negative, parabola opens down, and that will give me the maximum value. So I basically have to find the second differences. But before that, I have to find first differences. So 0, the difference between 0 and 5, 0 minus 5 is -5. Between 0 and -3 is going to be -3. Between -3 and -4 is going to be -1. And I can continue. I can see that the first differences, delta y, are not constant, and they're changing, but then I will find the second differences. So the difference between -3 and -5, so -3 minus -5 is +2, and over here is +2, and therefore I see that the second differences are positive. This parabola opens up, and therefore my optimum value is a minimum value. All right, let's compare that to a graph. So this is the graph for this table of values, and we can see once we plot them or use this step pattern 1, 1, 1, 3, 1, 5, and the same thing on the other side, we can see that the x-intercepts are -3 and 1, that the axis of symmetry falls halfway between them, and it occurs at x equal to -1. Axis of symmetry crosses the vertex at the point of -1, -4, and -4 would be the lowest y value, which is the minimum, and it's an optimum value. So this would be how to do it from the table of values, and this also can be, all those key features could be read from the graph. Let's investigate how many times a parabola can cross the x-axis. So let's draw a rough sketch of a parabola which opens down and has a vertex anywhere in quadrant 1. So if it's in quadrant 1 and opens down, I can see, we always do these arrows at the end, that it will continue in this direction. We can see that it will cross the x-axis in 2 points, which means it will have 2 x-intercepts. All right, there will be 2 x-intercepts for this one. Now let's see, let's draw a rough sketch of a parabola that intersects the axis only once. Well, you've already seen a parabola like this one. It was our simplest function, which was this one, and that crosses the axis only once. But of course, that parabola could be over here and opening up. It could be down here, opening down, and so on here, opening down, and so on. So we know that the parabola that only has one x-intercept is the parabola where the vertex of that parabola falls on the x-intercept. Okay? And sorry, when the x-intercept, when the vertex falls on the x-axis. All right, let's look at another one. Draw a rough sketch of a parabola that does not intersect the x-axis at all. All right, so there are a number of possibilities as well. This could have been a parabola that opens up. It's in the first quadrant, and it will never cross the x-axis. Another one could be here. So never draw as a V. It's always a very smooth curve. All right, that's another parabola that opens up, and it's in the second quadrant. There's also a parabola in the third quadrant, but we'll have to open down and will never cross x-axis. And there's another one in fourth quadrant and never crosses x-axis. Of course, they can also be in both quadrants, like here, this one, or this type of problem. So there are 3 different scenarios. You can have 2 x-intercepts, 1 x-intercept, or none of them. Let's have a look at another type of example. For the following parabola, state the zeros. All right, so we are reading the zeros, x-intercepts right from the graph. So for this one, it's very straightforward. I see that the parabola crosses x-axis at -1 and at -3. So I have 2 x-intercepts, 2 zeros. And it's very easy to read them right from the graph. But let's look at this parabola. This parabola opens down, And if I want to read the x-intercepts, I can see that this x-intercept falls between 4 and 5, and this one falls between 0 and -1. And I do not know exactly where they are. Therefore, reading them from the graph has its limitations. In order to know exactly where those x-intercepts are, I will have to provide you with an equation for this function. And the equation will be y is equal -x squared plus 4x plus 3. And in order to find those x-intercepts, I will have to make y equal to 0, since x-intercept occurs when y is equal to 0. So if I were to substitute 0 here, I will obtain a quadratic equation. And you already learned how to solve these quadratic equations. So I can rewrite it this way. Plus 3 is equal to 0. And first thing would be to try to solve it by factoring. And you'll quickly recognize that you cannot solve this by factoring. Therefore, you will solve this using quadratic formula, which is -b plus minus b squared minus 4ac divided by 2a. And when you plug it in those numbers, you will obtain a solution, and the solution would be x is equal to 2 plus square root of 7, or x is equal to 2 minus square root of 7, and that would be an exact answer for those x-intercepts. You can always approximate, and it will be around -0.64 or +4.6. And then if you go to the graph, it kind of matches. This will be about -0.64, and this one will be around 4.6. So the only way to know exactly when those x-intercepts are is by solving quadratic equation. So in conclusion, the x-intercepts, zeros of a quadratic function, parabola, the ones that you see on the graph, are the real solution, real roots of the quadratic equation.